Today we already have finished with our first session of class, and today we will be starting with your second session of your class on the same topic of your physics. We'll move on to the non-contact forces. In the previous class we have been discussing about your contact forces, right? They are under the classification of forces. Under your contact forces, you know that when two bodies are in contact, okay, that is your contact forces. And then when your non-contact forces is that the forces which do not require any physical contact between two bodies on which they act. That means this hand and this pen does not need to have a physical contact. Okay, what happens is that under non-contact force they need a physical contact between two bodies, but in non-contact forces this pen and hand doesn't need a physical contact between them. Okay, so under that you have first one to have is your electrostatic forces. Called electrostatic, it may be a little bit tricky, okay, but electrostatic it's nothing but it's all about charges. Okay, the charges which are stationary or the charges which are at rest. We know that there are many methods to charge a body. Okay, for example, it's been given there in your book is that a plastic comb. Okay, a plastic comb can be electrically charged by rubbing in our dry hair. Okay, if I take a plastic comb, okay, think that this pen is a plastic comb, and if I rub it on my dry hair, this plastic comb becomes electrically charged. Then what will happen is that when it becomes electrically charged, it will exert an electrostatic force. Okay, it will exert an electrostatic force on those uncharged tiny piece of paper. Okay, I have a tiny piece of paper here. Okay, here I have my comb which is electrically charged by rubbing in my hair, and then I have a tiny uncharged piece of paper. Okay, this uncharged tiny piece of paper. So what will happen is that if I bring this comb, plastic comb which is electrically charged, okay, near this tiny piece of paper which are not charged, it will attract them. Why? Because it exerts or it gives out an electrostatic force. Know that we can charge a body by rubbing it. Okay, so here I'll give you another example is that we take a piece of straw, and if I rub that straw with a sheet of paper, okay, here is my straw which I have rubbed with a sheet of paper. Okay, and then I take another straw. So this straw it's already been rubbed with a paper. Okay, so I take another piece of straw. Okay, another piece of straw. When I bring them together, what will happen is that it will start attracting each other. Okay, this straw was by rubbing it on the paper, it becomes electrically charged, and this straw I did not rub with the paper. Okay, but what will happen is that this straw will exert an electrostatic force. Okay, because how it exerts an electrostatic force? Because when I rub on a paper, it becomes electrically charged. Okay, so when it becomes electrically charged, it will attract the another straw and they will attract each other. Okay, and another thing, at the same time, suppose if I rub these two straws with sheet of paper, what will happen is that both will become electrically charged. And since both the straw I have rubbed them with paper, okay, and they have become electrically charged, if I bring them with one near one another, what will happen is that they will start, instead of attracting, they will start repelling from each other. Okay, so this means that some forces that are exerting between them, there are some forces that are exerting between them. Okay, so the force exerted by a charged body on another charged or uncharged body is known as your electrostatic force. Okay, because first what happened is that this pen was electrically charged and this pen was not electrically charged, and when you bring them near, what will happen is that they will attract one another. But another thing is that if both these two pens are being charged, okay, by rubbing on the paper, if they are being charged, what will they do is that they will not attract one another. Okay, so in both the cases you can see that there are some force exerting on it. So electrostatic force will be the electrical charge object, okay, where the force exerted either by a charged body on another charged or uncharged body. The force exerted on a charged body or an uncharged body, either by attraction or either by repelling, you can see that there will be some force being applied here. So this is known as your electrostatic force. Now next we'll move on to your magnetic force. Okay, this magnetic force is another force which can act as a distance. Okay, that is your magnetic force. These magnets, they have the property of attracting objects made of iron. Suppose this pen cap is my magnet. Okay, so think that this piece of paper is my iron. Okay, so if I bring this iron near the magnet, okay, the magnet will start attracting these things, okay, towards it. So this means that the magnet has applied force on this body. Okay, so the force exerted by the magnet is called a magnetic force. So what you mean is that what makes the magnet attract this paper, okay, I mean this iron? It is because there is some force in between here, this and here. So this magnet has given out or has exerted some force which allows the iron pin to get attracted towards itself. Okay, that is known as your magnetic force. The force that is exerted by a magnet, it's called as your magnetic force. You might also play with toys. Okay, like another thing is that they attract or repel because they have magnets inside them. If you have played with toys, you will see that they attract or repel with each other. Okay, they either attract or repel with each other because they have magnets inside them. And you should know that why do they attract? If you have a two magnet, that is your north pole and your south pole. Okay, suppose this is my north pole and this is my south pole. If I have my north and north pole, they will repel with one another. But if I have my north pole and south pole, they will attract. Okay, that's why repulsion happens in magnets. Remember that in magnets you have two poles, that is your south and your north pole. Okay, so if I bring my north pole of this magnet and another magnet of my north pole, they will not attract. That's why we say that they repel from one another. But if I bring my north pole and this part of south pole, they will attract. Means like poles will repel and unlike poles they will attract. Okay, next one you have is your gravitational force. This gravitational force is the pull of the earth. Okay, the pull of the earth. So we always see that things, they are falling towards the earth. Okay, we have also observed that water flows down the hill, objects they falls down towards the earth, and water flows down a slope due to the pull of the earth. Okay, can you ever answer why these things happens? Because the earth pulls it down. Okay, so if I have a pen and it starts falling, okay, whenever it falls, it always falls towards the earth. Suppose this is the ground, earth. Okay, so whenever if I drop this pen, when it falls down, it always falls towards the earth. Why is that so? Is because this earth, it pulls it down. When it falls, the earth pull it towards itself. Okay, so this pull of the earth is a force. Okay, when this pen falls down, the earth pulls towards it, and then this pulling of the earth, okay, when the earth pulls this pen, it is the force. A force is being applied, and that force is known as your gravitational force. Okay, the earth exerts this force on the body, okay, within the gravity regions of the earth. So remember that whenever you drop things, or whenever you see something falling down, whenever you drop, whether you drop a ball while standing on your balcony, if you drop the ball, it will always fall towards the ground, that is towards the earth. Why? Because the earth, they will pull the object towards themselves. Okay, they will pull this towards themselves, and you know that push and pull is known as your force. Okay, so when they pull that object towards itself, a force is being applied, and that force is known as your gravitational force. I hope you're clear with your electrostatic force. Electrostatic force mainly deals with which are electrically charged object. Then you have your magnetic force, which have where the magnets, they have the property of attracting objects, especially that are made of irons. And then you have your gravitational force. The gravitational force is the force where the earth pulls towards itself. Whenever any object falls, the earth will pull towards itself. okay, and that force is known as your gravitational force. Now let's move on to weight. Okay, so before I start with the definition of weight, let's move to mass first. Okay, you may wonder why I'm moving to mass when in your book it doesn't mention anything about mass. But in order for you to be clear with weight, okay, in order to be clear with the concept of weight, first let us know the difference between mass and weight. Let's know the difference between mass and weight. Okay, we often think that mass and weight is of similar term. We often think that the meaning is same, but actually mass is not similar to weight. Okay, both of them have totally different concept. Okay, whereas when it comes to mass, okay, first mass, it deals with the amount of matter, present in a body. Okay, and then whereas when it comes to weight, it defines about the force applied on the object by earth due to gravity. So we should always know that mass and weight are completely different. Okay, because when it comes to mass, you will know that how much the amount of matter that is present in the body. If you look at the definition of these two, they are completely different, right? So let me give you an example in order for you to be clear. Suppose this is the earth, okay, and here is the moon. Suppose on the earth you weigh around 75 kilogram, okay, your weight here will be totally different. Okay, you might weigh around 50 kilogram. Why is that so? Okay, because here the earth gravity, okay, the earth gravity means the force that is pulled by the earth. Okay, so the earth gravity here, it is more, so your weight is more here. You weigh around 75 kilogram. But when it comes in the moon, since the gravity is very low, your weight will be around 15 kilogram. Okay, but doesn't mean that the amount of matter or the mass that is present in your body will be less. It's just that due to the gravitational pull, okay, or due to the presence of gravity, your weight here is 75 kilogram, but your weight here is 15 kilogram. But suppose you are fat, okay, you are fat, and it doesn't mean that when you go to the moon you'll become thin just because your weight is 15 kilogram. Okay, you'll always remain fat too. Your size will not decrease. Okay, only your weight will decrease because the gravitational pull is less, but the mass, okay, that means the mass or the amount of matter that is present in your body when you're in the earth, and the amount of mass or the amount of matter that is present on your body when you're in the moon will not change. Okay, let me give you an example of water. Okay, you all know ice, right? So suppose ice is made up of H2O, 2 molecules of hydrogen and 1 molecules of oxygen. So let's think that in this ice you have 100 molecules. Okay, so this 100 molecules is your mass. Okay, the amount of matter present in this ice is 100 molecules. So if I want to move this ice this side or this side, it will not change the fact that there is 100 molecules inside this ice. Okay, so mass and weight are completely different. Weight indicates that the force that is applied on the object by earth, okay, due to gravity. So I hope you're all clear. So another one is that we also have a formula to calculate weight. Okay, so the formula to calculate weight, okay, it is weight equal to m into g. M will indicate the mass. Okay, I've already told you what is mass, and g will indicate the acceleration due to gravity. And as I've written here, the definition is the gravitational pull of the earth on a body. That is your weight. Okay, and then we should know, okay, and then you should also know that greater the pull of the earth on an object, the greater will be its weight. As I have told you, I have given you an example of a person. When a person is on the earth and when the person is on the moon, their weight will be completely different. Why is that so? Because of the gravitational pull. Okay, because due to because of the gravitational pull of the earth. Okay, so if the gravity is more on the earth, that means the person weight will be more. Okay, but if the gravity is less, that means the person weight will become less. Okay, and we should also know that the weight is measured. Okay, we can measure the weight with a spring balance. So if you want to know what is a spring balance, you can refer to your textbook, page 49, figure 3.10. Okay, so you'll all know what is a spring balance. Okay, so this spring balance, they are used for measuring weight because it has a spring. Okay, you all know what is spring, right? When you pull a spring, it starts extending. Okay, this is not a spring, so if I pull, it cannot extend. Okay, but a spring, when you pull them, it can extend. Okay, so since this spring balance, they have a spring which helps in extending the length. Okay, so if the object is heavier, what will happen is that the spring also will start extending more. Suppose if I have here the spring balance, okay, and if I put here a heavy object, what will happen is that this spring will start, if the object is very heavy, this spring will start extending longer. Okay, so that's why a spring balance is used for measuring the weight. Okay, so you should always know is that heavier the object is pulled by the earth with a greater force. Okay, so whatever object, if a heavy object is present, okay, it will always be pulled by the earth with a greater force. Okay, and as I have told you that for measuring a force, okay, you have a force, that force are always measured in unit, that is Newton, that is N. Okay, you can indicate with N. Now let's move on to adding forces. Okay, by the term adding, I hope you understand what is meant by adding. Adding, you know, right? When you add 1 plus 1 is equal to 2, right? That is adding. So in the same way, when it comes to adding forces, it means like when you add 2 or more forces, okay, and when they act on a body, the total effect caused by these forces that act together produces a single force. So that single force is known as your resultant force. Okay, so I think it'll be quite confusing. I'll give you an example. Okay, so now you have a car. Okay, think that this is a car. So you have a car here. So you have a car here, and your car has broken down and you're pushing the car. Okay, so when you push a car, what will happen is that your car will move slowly. Okay, this is your person A. Then you find one person standing here and is offering you a help. Okay, so when this person helps you to push the car, okay, one you're pushing and your friend is, this person B is pulling the car. So what will happen is that obviously the car will move faster, right? Then let's have another case, is that you have another car. Okay, you have a car here, and what will happen is that if you are pushing the car and another friend of yours help you to push the car, what will happen is that the car will move more faster. Okay, so this is your resultant force. Okay, when two forces, that is either one push and either one pull, or either both of you push the car, okay, what will happen is that two forces are being applied, right? That is you and this person A and B. When both of them are using both of their force, they form a single force, and that single force is known as your resultant. Okay, either they push in the same direction, either they push in the same direction, or either they use the force in opposite direction. Both, what happened is that two people are using the same force, right? They are using force. So when two people are using force, they form a single force, and that single force is known as your resultant. Okay, I've told you that if a force is being applied in the same direction, okay, here this A and B, they're applying the force in the same direction, right? They're both pushing the direction. Then how to get your resultant force is that, okay, there's a formula to get the resultant force, is that A plus B is equal to force A, that is your force A, this person, and plus your force B, since they are pushing in the same direction, okay, because the force is being applied on the same direction. Now what will happen if the forces are applied on the opposite direction like this A and B? The formula you will have is that force A, okay, your force A minus force B. If it's applied on opposite direction, it will be force A minus force B, okay? And if the force is applied on the same direction, it will be force A plus force B. Either way, either it's in opposite direction or either in the same direction, this is known as your resultant force, because a single force is being used when two, or as in your book as they have explained, is that when two or more forces they act on a body. Two or more forces they act on the body to produce a single force, it is known as your resultant force. So I hope you're clear with this.